Velocity versus time graphs are fundamental tools in physics that help us visualize and analyze motion. These graphs provide crucial information about how an object's velocity changes over time. A velocity versus time graph plots an object's velocity on the vertical y-axis against time on the horizontal x-axis. This creates a visual representation of how velocity changes over time. The most important feature of a velocity time graph is its slope. The slope at any point represents the object's instantaneous acceleration. Let's see how to calculate this slope. To find the slope, we calculate rise over run. The rise is the change in velocity and the run is the change in time. In this example, the slope equals 0.5 meters per second squared, which is the acceleration. Different line shapes tell us different stories about motion. A horizontal line indicates constant velocity, which means zero acceleration. The object is moving at a steady speed. A line sloping upward indicates positive acceleration. This means the velocity is increasing over time, like a car speeding up from a traffic light. A line sloping downward shows negative acceleration or deceleration. The velocity is decreasing over time, like a car braking to a stop. Another important feature is the area under the velocity time curve. This area represents the displacement or distance traveled by the object during that time interval. Here's a practical example. A car accelerating from rest. The straight line shows constant acceleration. We can read values directly from the graph and calculate the average acceleration. To summarize, velocity time graphs are powerful tools for analyzing motion. The slope tells us about acceleration, the shape tells us about the type of motion, and the area gives us displacement information. Acceleration versus time graphs plot an object's acceleration on the vertical y-axis against time on the horizontal x-axis. These graphs help us understand how an object's acceleration changes over time. A horizontal line at zero acceleration indicates constant velocity. When acceleration is zero, the object maintains the same speed and direction without speeding up or slowing down. A horizontal line above zero indicates constant positive acceleration. This means the object is continuously speeding up at a steady rate, like a car accelerating on a highway. A horizontal line below zero indicates constant negative acceleration, also called deceleration. This means the object is continuously slowing down at a steady rate, like a car applying brakes. The area under an acceleration versus time curve represents the change in velocity over that time interval. This is a powerful concept that connects acceleration graphs to velocity changes. When acceleration is not constant, the line will be sloped or curved. A sloped line indicates that acceleration itself is changing over time, while curved lines show more complex acceleration patterns. These acceleration graphs directly relate to velocity versus time graphs. Constant positive acceleration on an acceleration graph corresponds to a linearly increasing velocity on a velocity graph. Real-world examples help us understand these concepts. During a rocket launch, the acceleration increases as fuel burns and the rocket becomes lighter, creating an upward sloping line on the acceleration graph. When a car applies brakes, it experiences constant negative acceleration, shown as a horizontal line below zero. The longer the braking time, the greater the total change in velocity, represented by the area under the curve.